What are we going to do with the information that we're given about connecting negative derivatives to decreasing functions and positive derivatives to increasing functions? Or at least positive derivatives are where functions are increasing and negative derivatives are where the function is decreasing. One thing we can do is we can find intervals where our function is increasing or decreasing based on this knowledge. Let f be a differentiable function on an interval I. To find intervals where our function is decreasing and increasing, what we can do is a three-step process. First, we find the critical values of f. Second, we divide the big interval that I'm looking at, the I, into smaller subintervals based on where the critical values are. Once I know the subintervals, then we are going to check each subinterval for increasing or decreasing. And that means whether our function is increasing or decreasing. Visually, what do we mean? Well, here's what we're going to do. We're going to find the critical values. Remember, the critical values are where our function has either a 0 as its derivative or where the function has a derivative which does not exist. The reason why these critical values are so important is because in order for you to go from negative to a positive derivative, if I have a differentiable function, then I either need to go past a point where the derivative is 0, or I need to go past a point where the derivative does not exist. So as we have negative slope, it has to change over to a positive slope. So the negative slope changing over to the positive slope in this y equals x squared happens where the derivative is 0. And then we go back to a positive slope. So we can see that the places where our function changes from negative derivative to positive derivative have to happen at the critical values. So those critical values are going to subdivide our interval into places where we can have negative slopes versus positive slopes. And in between those subintervals, or inside those subintervals, the slopes are always going to have to be positive, or the slopes are always going to have to be negative. That's why this process works. The only place we can change from a positive to a negative slope, the only place where our derivative can change from positive to negative or from negative to positive is at a critical value. So we can divide any interval into critical values, or any interval into subintervals denoted where the critical values are, and then we can test each little subinterval. Let's see how this is done in an example. Example 1 asks us to find where the function is increasing and decreasing on the given interval. The function is f of x equals x to the third minus 6x squared minus 15 on the interval from -10 to +10. In order to figure out where on this interval the function is increasing and decreasing, we need to start by finding where the critical values are. That forces me to take the first derivative of my function f of x. The first derivative is 3x squared minus 12x. Now, 3x squared minus 12x is never not going to exist. It's always going to exist no matter what you plug in. So does not exist is not an option, but there are places where this derivative could be 0. So we set this derivative equal to 0 and we solve for x. In order to do that, factor out a greatest common factor, that's 3x. What's left over is x minus 4. By the 0 factor property, either 0 has to be 3x or 0 has to be x minus 4. Solving that, this means we have 2 critical values. One critical value is when x is 0, and the other critical value is when x is 4. In this case, our subintervals are going to be inside of the interval I. So in my case, 0 and 4 are both between -10 and +10. So I'm going to have to use both of them. The subintervals that I'm going to use are from -10 up to 0, and then from 0 to 4, and then from 4 to +10. Notice what I did there. I basically said from -10 up to 0. 0 might be a cutoff, so let's cut it off there. 0 to 4, 4 might be a cutoff, so let's cut it off there. And then 4 to 10. Make sure you go in order when you do that. You don't want to go from -10 to 4 and then from 0 to something else. That would not make any sense. Like I said earlier, because the only place we can change from increasing to decreasing is at the critical values, I know that between -10 and 0, this function is always going to be either increasing or decreasing. So it can't switch from -10 to 0. All I have to do is pick out a number between -10 and 0. Let's pick out the number -2. So -2, when you plug it in to the derivative, 3 times -2 squared minus 12 multiplied times -2 gives me a positive 36. Now, the only thing I really care about is the fact that this is positive. Because that forces my function, my original function, f of x, to be increasing on the interval from -10 up to 0. So my original function, I know, has to be increasing on -10 up to 0 because we got a positive first derivative. Let's do the next subinterval. The next subinterval is from 0 to 4. We want to pick out some number between 0 and 4 and plug it in to our derivative. I'm going to pick out the number 1 because that is easy to plug into the derivative function. So 3 times 1 squared, 3 times 1 squared, minus 12 times 1 gives a negative 9. The important part about that is that it is negative. So the derivative is negative, and because the only place we can change from negative to positive derivatives is at the critical point, this means my function has to be decreasing between 0 and 4. So the function f of x, the original function, is decreasing on the interval from 0 to 4. Let's look at the last interval. The last interval is from 4 to 10. The derivative in that interval, well, it's either going to be positive or negative. So let's plug in a number between 4 and 10. It doesn't matter which one you choose. I'm going to plug in 9. If you wanted to plug in 6, or if you wanted to plug in 5, or if you wanted to plug in 7, be my guest. I chose 9. When you plug in a 9, you get 135, which is positive. And we can see that the function, therefore, is increasing on the interval 4 to 10. So we know now that my original function increases between negative 10 and 0, then decreases between 0 and 4, then increases again between 4 and 10. And that all happens in between the bigger interval between negative 10 and positive 10. So that's how you deal with knowing where my function is increasing and where my function is decreasing. Like I've said before, if you would have chosen some other number between 4 and 10, you would have gotten out a different number. It wouldn't have been 135. For instance, if you would have plugged in the number 6 into the derivative, you would have gotten just a 36, but it's still positive. No matter what you plug in between 4 and 10, we're getting a positive number. Notice we don't plug in 4, obviously, and you don't want to plug in 10, but any number between 4 and 10, you get a positive output, and therefore you know your function is increasing along that interval.